Hi there everyone, welcome back to the channel. So in this video, we are going to learn about asynchronous JavaScript. We are going to learn asynchronous JavaScript from the very basics, and we are also going to discuss some of the advanced concepts of JavaScript. Also, we are going to discuss some of the internals of JavaScript, like how JavaScript actually works, how JavaScript executes its code, like talking about execution context. And also these are the topics that we are going to learn here. Execution context, whether JavaScript is synchronous or asynchronous, why is asynchronous important, right? And whether JavaScript is single-threaded or multi-threaded, what is call stack, what is callback and callback hell, promises, async await. So we are going to discuss all of these concepts here. We're going to tackle these concepts one by one. We are going to start from the basics and then we are going to move towards the advanced concepts. So let's start. Now, before we dive into asynchronous JavaScript, it's important that we understood execution context in JavaScript. Trust me, once we understood this execution context, it is going to be very much easier to understand what is asynchronous and how JavaScript achieves asynchronous nature. So first, let us understand what is execution context. So here I have written a pretty good block. So I'm going to explain it to you via this block. So let's start with this question. What the heck is execution context? So simply put, execution context is the environment where all your JavaScript code runs. Like literally every line of code you write gets executed inside the execution context only. So execution context is like a wrapper so that every single line of code you write that stays inside the execution context and that gets executed inside that execution context only. Now, as you can see here that I have written some of the lines of code here inside this app.js file. So now as soon as I create this app.js file, a new execution context was created by the JavaScript engine, and that execution context that gets created as soon as we create this .js file is known as global execution context. And whatever the code that we have written inside this app.js file that gets stored inside this global execution context. Now let me explain it to you a bit more graphically. So let me copy this code and come here first. And inside the console tab, let me paste this code and hit enter. As you can see, the code got executed and we got the respective output. Now I want to explain how does this code got executed. So for that, I've drawn a pretty good diagram here. So this is what execution context looks like. Now you might be saying, hey Rajesh, what is this complicated diagram all about? So don't get scared by looking at this diagram. I'm going to dissect this diagram piece by piece and I'm going to explain it to you in the best easy way possible so that you can understand it. So as you can see that whole this rectangular box is known as execution context, or rather what we can call it as global execution context. So as soon as you create this .js file, this big box gets created by the JavaScript engine, which we call as global execution context. And by now you can say that this global execution context is divided into two phases. So it has got memory phase and then the execution phase. So what are these phases about? So first, now I think this much is clear that what is execution context or the global execution context. It simply means whenever you create a .js file, a global execution context gets created by the JavaScript engine, and all this code that we have written inside the .js file, it gets allocated here. How it is going to get allocated, that we are going to understand now. So if I come to this article a bit here, and then you can say that this execution context is created into two phases. So memory phase. So the first phase is your memory phase. So in your memory phase, all the variables and functions from your JavaScript program gets allocated in the memory. All right. So that's what memory phase is all about. And in the code execution phase, the JavaScript program gets the JavaScript program gets executed. All right. So if I come here, and then if I show you this code example, let me come here. And as you can see that here I have created this variable which is saying var say hi, and I'm assigning it as hi. So as I told you that inside the execution phase, the first phase is memory phase. So inside the memory phase, whatever the code I have written, all this code needs to be stored somewhere in the memory, right? And then only it gets executed. So the process of allocating all this code inside the memory is known as memory phase. That happens inside the execution context. So how does this happen? It happens line by line from top to bottom. So the first here we have declared is var say hi, right? So this variable say hi gets allocated inside the memory in the memory phase, and it is initialized with undefined. So whenever we declare a variable using var keyword, it gets allocated memory and it is initialized with undefined. Now you might be saying, hey Rajesh, we have initialized with hi, how come this undefined? So bear with me. Initially this is just a memory phase. All this thing, initialization, execution, logging, happens inside the execution phase. Right now the JavaScript engine is just allocating memory to the code, right? So the var variable is getting allocated inside the memory and it is being initialized with undefined. And now similarly we have another variable which is verified. Again it is going to be initialized with undefined. And if we come here and see that I have one more function which is grid. Right now this function also gets allocated inside the memory, and then now this, after getting allocated, this grid function is going to store all of this entire function only. All right, and now once the memory phase is done, we'll move towards the execution phase. So inside the execution phase, JavaScript tries to execute code one by one. So how does JavaScript execute the code? So let's say, so in the first line we can see that the JavaScript engine says that the variable say hi is being initialized or assigned with value hi. So what is going to happen is now this undefined is going to be replaced and we are going to get hi here, right? So this is happening inside the execution phase, right? So now JavaScript is allocating this hi inside this say hi variable, and then let's see that in the second line of code we are logging console.log say hi, and there we go. We got hi, the hi got logged out. And then now in the second line it is logging 1, so we are getting 1. And in the third line again we can see that is verified is being initialized with true. So now all this is happening inside the execution phase. And now here JavaScript engine, what it does is it removes this undefined and it is going to be initialized with true. And then we can see here now we are logging is verified and then we got true here. So that's how JavaScript codes get executed inside the execution phase. But guys, this is just the half of the story. As I told you that whenever we create a .js file, a global execution context gets created, and whatever the code we have written, it gets allocated inside the memory in the memory phase, and then it gets executed once the memory phase is done inside the execution phase. But whenever we create a function inside this JS file, a new execution context gets created inside the global execution context. Yes, always remember, whenever a function gets declared or whenever we create a function inside the JavaScript file, for that function, JavaScript engine creates a new, completely new execution context, which we also call as function execution, right? And that execution context gets created inside the global execution. Why it is getting created inside the global execution? Well, because we can see that this function is created inside this .js file only, right? And this global execution context is created by this .js file. And since we are creating this function inside this .js file, so for that function, a new execution context is being created inside the global execution. So now you always remember that whenever you see a function inside the JavaScript, always remember that this function is going to create a completely new execution context inside the global execution context, and that new execution context is also known as function execution. Again, this new execution context or the function execution is divided into two parts, same story, the memory phase and then the execution phase. And as you all know by now that in memory phase, the code gets allocated right inside the memory. So here the var message we have, so this message gets allocated inside the memory, and since the message variable is declared using the var keyword, it is being initialized with undefined. And once the memory allocation phase is done, we move towards the execution phase where the JavaScript code start executing one by one, line by line from top to bottom. And then here we can see that message is being initialized with this beautiful message, hello viewers, have a great day. Right now this undefined is going to be replaced with this beautiful message, and then after that it is going to log us this message, and we are going to get this message here. All right, and then after that, as you can see, there is a return keyword. Right now this return keyword is really important. Now as soon as the function hits the return keyword, what happens is this execution context gets completely deleted. Yes, this entire function execution context that we have created, this gets completely deleted whenever a function hits the return keyword. Okay, always remember, whenever we create a function, a new execution context gets created, and whenever we write return keyword, and whenever a return keyword is hit inside the function, that newly created execution context gets completely deleted from the global execution context. Now you can call this as function, this execution context is no more, it is completely deleted, and it goes back to its global or the parent execution context, and then it start executing further code. So that's how JavaScript works, right? And then now let us dive a deep more. Now that we have understood that there are multiple execution contexts, there can be multiple. The first is the global execution context, and then the more functions you create, more execution context gets created, right? So let's just say there is another functions that you have created, which is simply saying hey. All right, now again another execution context is going to be created here. All right, outside in the global execution phase only, inside the global execution context only. But let's say what happens is, if you clear this function and then if you come here, and then what happens if you write this function inside this grid function only. So what is going to happen is, now inside this execution function execution, again a new execution context is going to be created, a new function execution context is going to be created, right? So that is going to happen recursively, you can say. Now by now you understood that JavaScript engine needs to be deal with a lot of execution context, global execution context, and there are so many function execution contexts, right? So for that we need something to manage all those execution contexts and run JavaScript code one by one from top to bottom. So for that we have something called call stack. So that's why we call call stack as manager of all the execution contexts, right? So here it is written, as you know, at first a global execution context is created, and later every time a function invocation is done, means every time a function is called, a new execution context get created. Now so in order to manage all this bunch of execution context, we have something called call stack. So all the execution contexts are placed in the format of stacks in the call stack. So basically call stack, what it does is it manages all the creation and deletions of execution context. So let us try to understand call stack a bit deeply. Now before we move here, now we can clarify that JavaScript is a synchronous single-threaded language. So what does this mean? This simply means that, as you can see, that JavaScript code gets executed from top to bottom, line by line. So that's what means synchronous single-threaded language. So synchronous basically means it is executing code line by line from top to bottom. First it is executing line number 1, and then it is going to execute line number 2. So that's what synchronous means. And what is single-threaded? Single-threaded basically means that when it is executing line number 1, it does not move towards executing line number 2 until line number 1 is completed, right? So let's just say it is initializing here, variable c high is being initialized with high, right? So now before this initialization is done, before this line number 1 is completed, JavaScript engine won't move to the console.log and then it log high. No, it won't do that. It is first going to complete this line number 1, and then only it is going to log this high. So there is no parallel execution, there is serial execution. So that's what single threaded basically means. So thus we can conclude that JavaScript is a synchronous single threaded language. Now we can understand this concept much more when we understand these concepts of call stack. Now by looking this diagram, you might be confused. Hey, this is quite a complex diagram. Hey, what is this call stack you're writing? Web API, and here you have all this bunch of diagrams. I don't understand. So bear with me. Again, I'm going to explain it to you piece by piece. I'm going to dissect every piece of this diagram, and I'm going to explain it to you in the most easy way possible. Okay, now you guys have known that how the execution context gets created and how this code is executed. But we also understood that in order to manage all this execution context, we have something called call stack. Now we are going to see how call stack is going to manage all this execution context. As I told you that first, whenever we create this .js file, a global execution context is going to be created, right? So that global execution context is what called main here. All right, guys. So whenever we create this .js file, this main function, which you can call it as a global execution context, it get pushed inside this call stack. All right. Now you can say that this entire big box or the global execution context is being pushed here inside this call stack, right? And now it start executing this global execution context, right? Call stack starts executing it. So here inside this global file, if we come here and then see that here we are initializing the variable, we are logging hi, we are logging 1, and we are logging is verified also. And let's just say here we are calling this grid. All right, and let's just say we are calling this grid here somewhere here in the between, right? So let me come here and let me call, and then let me show you how this code gets executed, right? So let me copy this, let me come to the browser here, let me refresh this. All right, clean this, come here, paste it, and just hit enter, and let's see how this output is going to be. Here first we got hi, we got hello viewers, we got 1 and true. Now we are going to understand how is call stack executing this code. All right, so let's understand. So as you can see, for .js file, it is going to create a global execution context, which is known as main. All right, and after that, the call stack is going to execute the code line by line, one by one, from top to bottom inside the global execution context. So what do we have here? First, we are initializing say hi with hi. It is going to initialize, and it is going to log hi, and that's why we got hi. But notice what I told you. As soon as a function invocation is done, as soon as we call a function, a new execution context is going to be created inside the JavaScript, right? So here I have shown you a new execution context with memory and execution phase. So here, once it is logged high, it shows that a function invocation is being done here. So inside the call stack, now again, a new execution context is going to be created here. So here it is simply going to be known as grid. Okay, so here we can replace this with grid. All right, now instead of executing all the rest of the code, it is first going to execute this grid. Why? Because we have created a new execution context. Now call stack is going to focus whatever the code that we have written inside this, instead of focusing on this rest of the code. Why? Because I told you that JavaScript is synchronous single threaded. So first it's executed line number 20, and then it executed the line number 21, and then in line number 22 what do we have? We have this function. So now it needs to execute this code. Without completing this function, it won't move to line number 23. So that's why it created a new execution context inside the call stack grid, and now this grid function is going to be executed inside the call stack. So here what do we have? We have this where message being initialized, and we are logging this message, right? So that's why after hi, we get this beautiful message. Hello viewers, have a great day. I hope all of you are having a great day, right? And then once the execution is done, now we have this something known as return keyword. And I told you, as soon as JavaScript engine sees the return keyword, it deletes the execution context, right? So it believes that this function execution context is completed, and then it is going to delete after seeing this return. Now it has hit the line number 30, it has seen the return keyword. Now it is simply going to delete this grid. All right, so it is going to be gone away from this call stack. Now what do we left? Again, we are left with the main. Now where does the control goes? Now control goes again to the line number 22, because well, we were executing the code line number 22, right? And then after that, once this is done, now the control goes to the line number 23, and then now it is going to execute 1 again. All right, and then that's why we are logging 1, and then after that again it goes to the 24, initialized with true, and in the 25 we will be logging is verified, which is true. So that's how call stack works, guys, and that's how call stack manages all these execution context, and it is going to execute your code line by line from top to bottom. And that's why this statement is pretty popular, and that's why we call that JavaScript is a synchronous single threaded language. That's what this all about. So alright guys, now that you have understood what is execution context and the synchronous nature of JavaScript, now let us understand what is asynchronous programming and why it is so important, right? So first let me delete this block, and as you can see here in the MDN docs, they are saying asynchronous programming is a technique that enables your program to start a potentially long running task and still be able to responsive to other events while that task runs, rather than having to wait until the task is finished. Once the task is finished, your program is presented with the result. So a lot of jargons here. Let me simplify it to you. So now consider that this piece is displaying some video here. It is rendering some kind of video and you're watching a fun video out here, but the video is not being completely loaded. All right, you are streaming videos, right? So the video is being loaded on the way. Well, video is loaded. Let's just say video is being loaded, displayed only into this portion, and let's just say in this area we have some kind of a chat section, right? Here the video is being played in the middle, and here onto the right hand side we have some kind of a chat section. So what you want to do is, let's just say there are a bunch of people who have joined in this chat section, and you're watching a video here inside this browser, and other people are also sharing the same video in their browser. And now what you want to do is you want to chat about the video you're watching with your peers, right, inside the chat section. So now what you're doing is your browser is parallelly processing. Well, it is continuously displaying or playing video for you. It is continuously loading the video data for you. At the same time, you are able to chat also. So that's what asynchronous programming basically means. So in simple terms, you can say that it is running your code parallelly. At the same time, it is running your code to load the video, and in the other hand, it is also running the code to send and receive the message. So that's what asynchronous means. Let's just say if your browser is not capable of running asynchronous tasks, then what is going to happen is, let's just say if you're watching this video, then you won't be able to send the chat messages to your friends. Only once the video gets fully loaded, then only you will be able to send chat messages. But that's a bad user experience, right? You don't want that to happen. You want your web page to load the video, and at the same time you want the messages to be sent and received as well, right? But I think you might be confused now. Just now I have explained it to you that JavaScript is synchronous single-threaded language, and all the web pages are built using JavaScript. And the web pages allows us to perform asynchronous tasks. While watching the video, we can also chat, and that pages are also built using JavaScript. So how are we achieving this asynchronous nature? Well, we are going to understand now that. All right. So like by default, JavaScript is synchronous in nature, but there are some ways through which we can make JavaScript asynchronous and we can achieve asynchronous tasks. I hope now you understood what is asynchronous JavaScript and why it is so important. Now we are going to understand how can we make synchronous JavaScript asynchronous in nature, right? Now, in order to make JavaScript asynchronous, we have something called callbacks. Yes. So now we are going to start with callbacks and callback help. So in order to make JavaScript asynchronous, we use something called callbacks in JavaScript. So let us understand what is callback. Firstly, now you understood that JavaScript is synchronous in nature. Now, if we want to make our JavaScript code asynchronous, we use something called callback. But what is callback actually? So let me explain it to you with an example. So let's just say that you want to fetch a user data and you want to get the user email from there. And once you fetch the user data and get the user email, after that, what you want to do is you want to send a beautiful email to that user, right? So the first task here is to fetch that user data. And then after that, what you want to do is once you receive that email data, now using that email data, you want to send an email to the user. So I'm going to show you how can you achieve this task using the callback. So for that, first let us create a function which we'll call as fetch data. Now this function is going to be responsible for fetching the user data. All right. So how this function is going to fetch the user email? Well, using the username. All right. So here we'll be passing the username, and using this username, this fetch data function is basically going to get the email of the user. And let's just say we made some kind of an API call using the username and we got the data here. And let's just say we got a user email. So which is going to be, let me write email, and here I'm going to write your username @gmail.com. So let's just say we got this username, and then using this username we made an API call and we got the email of that user. All right, now what we can do is we can make another function for sending an email. So let us create another function which is, I'm going to name it as send email. All right, and then I'm going to receive some data out here, and then it is simply going to say const message or email is simply going to be, let me write hey, and I'm going to simply say data.email you are successfully registered. Okay, so let's just say this is the email message that we want to send to the user, and we are simply going to log this message here. Okay, now what we can do is we can use callback in order to achieve this task. We don't want to send email immediately, right? We want to wait for some time. We want to wait until this user email is being fetched, and once the user email is being fetched, then only we want this send email functions to be executed, and then it is going to send the email to the user. So how can we achieve this? This thing can be achieved using callback. So what we are going to do is simply here, first we are going to call this fetch data function, and we are going to pass the username. Let's just say I'm passing my username here, and then now we are also going to pass this function. Yes, literally JavaScript allows that. JavaScript allows you to pass function as a parameter, and this is your callback, right? So this is that simple. Whenever you're passing a function as a parameter, that is known as callback. So right now you have created callback, guys. So you have created this send email function, and what you are doing is you are passing this send email as a parameter to this fetch data. This is callback. It is that simple. Now you are simply going to receive this function which is send email, or you can simply name it as callback also. Many tutorial write this as CB, but I don't want to confuse you. I just want to make sure that this is exactly the send email function that we are receiving here. So I'm just writing this send email here. All right, and then here what you can do is, once the user has received this data, after that only you can actually call that function and you can pass this data here, right? So this is your callback. It is that simple, guys. So the function that you have called here actually is your callback function. All right. So in simple term, callback is nothing but a function that you are passing as a parameter to another function. Here this send email is your callback. So we have this function fetch data, and you are passing this send email function as a parameter to this fetch data function. And what this fetch data is doing is it is first fetching the user email using the username, and then since now this fetch data is receiving a function which is known as send email as a parameter, which we call as callback, and now it is simply calling it here by the data that it has received, right? So that is your callback. It is that simple. And now once the data is being fetched, then only it is going to call this function. And then once data is fetched, we are going to call this send email function with the data, and then once it is going to be executed, the control is going to come here and it is going to send us this message. So that's your callback, guys. And now what we can do is, if we can come here and copy this code, and if we come to the browser, we paste and we hit enter, there we go. We got this beautiful email message, like we were successfully sending this message to the user that, hey rajesh@gmail.com, you are successfully registered. So that's what callback basically means, and that's how you can achieve asynchronous nature in JavaScript using the callback. And like we have other things like web API as well. So browser give us something known as web API, using which we can achieve that callback asynchronous nature of JavaScript as well. Like let's just say I can give you an example. Let's just say we have a button here, right? So let's just say we have a button that we are grabbing it using DOM. So simply we are going to say document dot, let's just say query selector, and let's just say it's a button which is having an ID of register button. All right, so we grabbed here. So what we want to do is, as soon as user hit the register button, then what we want to do is we want to registered user, right? So we don't want this function to run immediately. We want to wait until the user click that register button, and then only we want to call that function and register that user. So for that, what we do is we simply do button dot add event listener, and we listen to an event called click, right? And then we simply pass the function here again. Now this function is known as callback. So just using this function, we are passing a callback here. I have shown you, right? So this send email, we pass the send email function as a parameter, and I told you whenever we pass a function as a parameter, we call it as callback. So again, browser API also uses callback to achieve asynchronous nature. And now what we are doing is we are passing this callback and we are listening to this click event listener. Now as soon as user click this button, now this function is going to be run, and then we can simply register user. So we can simply say registered. All right, we can simply print the message registered. All right, so how this add event listener and click event works? So for that, again, we can go to this diagram here, our call stack diagram, and then I'm going to explain you here in depth. Now what happens is, as soon as JavaScript says something known as click function, it is going to take that callback function and register it into the web API. Yes. So first, you all know that when we create this .js file, global execution context gets created and start executing the code, right? And whenever, let's just say, it start executing all this above line of code, and then after that, let's just say JavaScript engine shows this add event listener click. Now as soon as JavaScript sees this add event listener which is having click and it is callback, so what JavaScript engine does is, instead of putting this function here inside the call stack, it is not going to put that. Rather, it is going to register that function inside this web API only, right? So here we can say that we can come and we can say here click callback. All right, I'm just typing randomly here. So as soon as JavaScript shows this click event listener, it is going to register this callback function here inside your web API. Instead of registering here into the call stack, it is not going to do that. Why? Because, well, as soon as you know that we register something inside the call stack, it is going to execute this code immediately. But do we want to execute this code immediately? Do we want to execute this callback function immediately? No, we don't want to execute it immediately, right? We want to execute this function only when user clicks it. So for that, what JavaScript engine does is, it takes this click callback function and then it registered into the web API, and in the meanwhile the call stack is busy executing some other lines of code, and it is going to continuously listen to the click function. And let's just say, as soon as some user comes and click that register button, hit that click button, what it does is it triggers this web API, and then now what this web API is going to do is, it is going to send this code to the call stack. Well, no, it is not that simple. Why? Because let's just say call stack might be executing some lines of code here. So let's just say there might be some code here. I'm just writing console.log, and let's just say I'm just typing hey here. But let's just say this code is a pretty expensive code, and let's just say this code is going to take some huge amount of time to execute, and let's just say this call stack is busy executing this code. Now if this web API throws this code into the call stack, it is not going to execute, right? Call stack is simply going to be confused, hey, which code to execute? I'm busy executing this huge line of code, right? So what this web API does is actually it gives this code, or it throws this code inside this something known as callback queue. All right, so callback queue basically it stores all these functions that are ready to execute. So that's what callback queue does. So first it gets registered into the web API, and then this web API listens to the click event, and as soon as the click event occurs, it sends this code to the callback queue. And basically whatever the code which you can see inside the callback queue, all those codes are now ready to execute. All right, so that it simply means that this callback the code that you can see inside the callback queue are ready to execute inside the call stack, but right now call stack may be busy executing some other lines of code, right? So how do we know that whether call stack is free or not? And then call stack is free, then we need to finally move this click callback inside the call stack. So how does this happen? All this thing is managed by something known as event loop. As you can see this circle here, this is your event loop. So what event loop does is it continuously monitors this callback queue and then call stack, and then it is going to say, hey call stack, are you empty or not, are you free or not, right? Then let's just say if call stack is busy executing some huge lines of code, then call stack is going to say, hey, no, I'm not free right now, I'm pretty much busy with executing this expensive code, I'm not free at all. And then event loop continuously keeps on checking whether the call stack is free or not. And let's just say once the call stack is free, it is done with executing that heavy code. Now call stack is free. Now the event loop is going to see that, well, now call stack is free. Now what event loop is going to do is it is going to take this click callback function from this callback queue, and then it is going to place here inside the call stack, and then the code is going to be executed inside the call stack, and finally we'll be getting this register out here. All right, so this is how this entire setup diagram is going to work. So firstly, any code you see inside this .js file, it comes inside the call stack, and then it is going to be executed one by one. But whenever it sees something known as add event listener click, or if it says something called set timeout, all right, so all these are browser's web API. All right, so these are not JavaScript code. So some of you might think that this set timeout is a JavaScript code, or this add event listener click is a JavaScript code. No, this is not JavaScript. Basically, these are the APIs given by the browser to the JavaScript so that we can make our code asynchronous. And that's how, using this browser's web API, we make our synchronous JavaScript asynchronous in nature. All right, and whenever the JavaScript engine sees this browser's API like set timeout or add event listener click, it doesn't allocate it directly to the call stack. First it registers to the web API, and then it waits for that events to trigger. Let's just say here set timeout, it is waiting for 3 seconds. Then first it is going to register it to the web API, and it is going to wait for 3 seconds. And then once 3 seconds is done, it is going to send to the callback queue, and here the event loop is continuously monitoring between the call stack and the callback queue. And once the call stack is empty, event loop is going to take that code from the callback queue, and then it is going to put inside the call stack, and then the call stack is going to execute this code. Now I hope you understood this entire diagram, all right, and I hope you understood the importance of callback and how it helps us to achieve asynchronous in JavaScript, and also the importance of browser's API. Without browser's API, it wouldn't be possible to implement asynchronous nature in JavaScript. Now let us try to understand what is callback hell. So basically callback hell is nested callback. Let's just say you have a callback, and inside that callback you have one more callback, and inside that callback you have one more callback, and inside that callback you have one more callback. So you have a long chain of nested callback. So when you have that, this is something known as callback hell, which developer hates actually. So you can see this is a pretty complicated code, right? So whenever we need to nest callback, it becomes kind of a hell scenario. So that's why developer like to call this thing as callback hell. So how this callback hell happens? So let us try to understand here. So first, let's just say we have this face data. We are passing the username. We know that we need to get the email in order to send the email, and we have this send email function. And let's just say this send email function is also expecting a data and then a callback function. So now what is going to happen is we are going to get this email here, And then now we are going to call this send email function. And you know that send email function is expecting data and a callback function. So we are passing a data, and now we are passing one more callback function. And here we are passing an email. Okay, we are updating the email. Let's just say, so this task is for updating the email. So we are just updating the email, update@gmail.com. And let's just say we want to do additional check out here. Let's just say we want to send real email, or let's just say we want to verify whether it's a real email or fake email. So for that, again, we introduced one more callback function inside this. And then again, we are doing some kind of additional check. So as you can see here, that first we have this one callback function, and one callback function. Inside this we have one callback function, and again inside this we have another callback function. So we have nested the callback function one after the another and made our code pretty complicated. And this kind of scenario is what we call callback hell, and developer really tries to avoid it, and nobody wants to go into this scenario which is called callback hell. And the good news is we have solution to this. We have solution to this inside the JavaScript, which is known as promise. So promises basically simplifies the callback, and it avoids something called callback hell. So if we want to implement callback, then we can implement callback using promises without going to the callback hell scenario. So now let us understand what is promise and why it is so much important. Now, as I told you that promises is a better alternative to implement asynchronous instead of callback, right? So let us try to understand promises using this mtn docs. Here it says that promise basically represents the eventual completion or failure of an asynchronous operation, right? So what does this basically mean? So let's just say we have this sign up button, right? So when we click this sign up button, we enter our username, email ID, and we enter our password, and we click the sign up button. Now as soon as we click the sign up button, do you think that we immediately got result? No, we don't get immediately result, right? Whether that we are registered successfully or not. Why? Because as soon as we click the sign up button, your username, email, and password is going to go to the backend, to the database, right? And it is going to do some kind of authentication check, and it is going to figure out whether your email is correct or not, whether the username is available or not. And once all those check is performed, then only you will be able to register it successfully, right? So that means as soon as you click the sign up button, you are not going to get that data on the spot, right? You need some time to wait it. So for that kind of scenario, right? So this is an asynchronous task, right? So you are not getting the eventual completion immediately. You need to wait for the result. So in order to implement that kind of a task, right? So we use something called as promise or callbacks, as you all know. But we know that we have seen that using callbacks too much is not that much of a good idea, because we can run into something known as callback hell. So we have better alternative like promises, which helps us to avoid callback hell, and then we can achieve asynchronous task. So that's what eventual completion or failure. Basically, when you click on this sign up button, you won't get data immediately. That's why eventually you are going to get that data in the future after some seconds, right? After some time, whether you are registered successfully or not. Because if your email is faulty, then it is going to throw you an error, right? So that means you might get a failure also. And if your email and username and password, everything is correct, then it is going to give you a success, right? So that is eventual completion, right? So promise basically represents that eventual completion or failure of some asynchronous operation. In our case, the sign up, right? So now the promise is basically divided into three steps. The first is the pending state, which is also known as initial state. Means it is neither fulfilled nor rejected. That means it is a state when as soon as you click the button, now that check is going on in the server, right? You are not getting the data immediately. So at this point of time, the promise is in its initial state, which we known as, or which we call as pending state. At this moment of time, you are not registered successfully, or either you are not getting any kind of error also. So you are neither fulfilled nor rejected. So this is a pending state. And now we have another state which is fulfilled. Let's just say your email, password, user ID, everything is clear. Then you are going to get success message and you will be registered successfully. So this is known as fulfilled state. Now another third state we may have is a rejected state. So let's just say the username is not available, or you have used a faulty email. That means you cannot register there successfully. So you're going to get that some kind of an error. So that is known as rejected state. So let us see how can we implement promise. Now I hope you understood what promise is. Now we'll try to simply implement the promise. So implementing promise is pretty easy compared to the callback, right? So we just need to write promise, and in order to, let me fix this typo here, and in order to implement the promise we use this new keyword and call this promise constructor, right? So we call this promise constructor, and this is basically going to take a callback function, right? So let me add semicolon here, and here this promise constructor is simply going to take a callback function, and this callback function is going to take two things. It is going to take either resolve or reject, because as we all know that a promise is going to give us the eventual completions of data. Here it is told in the definition, right? So the eventual completion will be either success or failure. So the promise needs to represent these two states, right? So you have hit this sign up button. Now whether you are successfully registered or you have failed, you got some kind of an error. So for that we have resolve and reject. If you are successfully registered, then we use this resolve, and if you have failed, then we are going to use this reject keyword. So since it is going to take the callback function, which is going to have two parameters, resolve and reject. All right. Now here we are going to mimic that scenario of registering the user. Let's just say user click that register button. Now we made an API call here. After user has clicked the register button, we made an API call, and eventually we got some kind of a data by the API call. Now that data is going to tell us whether the user is successfully registered or not. So for that, this data is going to have something called status. Okay. So now let's just say if the status is 200, that means user is registered successfully. But if we get status like 400, that means there was some kind of an error and user was not able to successful. And at the same time, it is also sending us some kind of message. If user is successfully registered, then it is sending this success message. All right. Now we got the data. Now we can use this resolve and reject, and then we can send the message. All right. So let's just say if the user registered is successful, then we can use a if statement here, and we can say if data dot status is equals to 200, that means user is successfully registered. Now if the registered is successful, then we are going to use this resolve here. All right. And let's just say this resolve is sending us this message, and the message is, let's just say it is just sending us whatever the message that we are getting from the data. So it is simply going to say data dot message. All right. And I actually missed a semicolon out here. All right. So we are going to send exactly the message that we are getting from the server using data dot message. All right. So we just are sending this message, and let's just say if the status was not 200, that means we failed, right? So in order to send that failure condition, we need to send some kind of error. For that we use this reject. All right. So we will be using reject here, and then we are again going to send the message here. So we are simply going to say the message, and we are going to say data dot message. All right. So now we have what we did is we actually defined our promise. Now once we defined our promise, we need to use this promise also. So how do we use this promise? So it's pretty simple. So what we do is we simply use promise that we have declared in using this variable, and then now we simply use dot then. All right. We simply use dot then, and we simply take the data and we simply try to log the data. So let me explain it to you clearly here. So this dot then basically it represents the success state of a promise. Let's just say we register data successfully, and if we register successfully, we are going to send a message using this resolve, right? So now this dot then basically resolves the success case. So whenever the result is sending some kind of a message, in the case of success, we can access that message, that this object that we are sending using this dot then, and this object is going to be coming in place of this data, and then we are simply logging this data here. That's all. But what if the message is rejected, right? What if the user has entered some wrong credential and he was not able to register successfully? So how do we receive this rejected message? So in order to receive this rejected message, we have something called dot catch. All right, and here it is going to give us the error. And let me remove this semicolon. Actually, we can't use this semicolon here. And here we are simply going to log that error here. So whatever the message that we have sent, that is going to become in place of this error, and we are simply going to log the error. Now the promise either might be fulfilled or rejected, right? Either succeed or failure. So if the promise is succeed or it is fulfilled, then the dot then is going to run, dot catch won't execute. And if the promise is failed, if we are getting some kind of an error, then dot then won't run, dot catch is going to be executed, right? So in this case the promise is succeed. So let us try to copy this code and let us try to see the output here, right? So instead of logging, basically let me type error here so that we can get beautiful error message also. So now let me copy this code and let me go to the browser. Let me come here and let me clear this and let me paste this and let me hit enter. And there you go, right? We got promise as fulfilled and we got this message as success. Why? Because as you all know that the status was 200, and if status was 200 means it means success, and we got this data using the result. So that's how promise basically works. But what if it was failure? So what if the message was 400, right? So how does this work? So let us try to tackle that scenario as well. Now let me refresh this and let me paste here and let me hit enter, and there you go. All right, so I have forgot to change the message, guys. So let's just say we got failed to register. All right, let me simply type failed to register. All right, and well, basically this data is going to come up dynamically from the server. Here I'm just hard coding it. Okay, and now let me refresh this one more time. Let me come here and let me paste the code and let me hit that enter, and there you go. We got this error message. Well, because the status was 400, that means it was not success. So we are sending this message using this reject, and we are getting this error message which is saying failed to register, which was delivered to us by this dot catch. So success is delivered to us by dot then, and failure is delivered to us by dot catch with respect to resolve and reject. Now promise also provides us some awesome methods like promise.all, promise.any, promise.all settle. Like you can come here and you can read through the documentation also. Actually reading documentation is a pretty good practice. If you want to become a very good developer, then make sure you make the habit of reading documentation as well. So I have explained the promise part. Now I'm giving you this as an assignment that you come here and read the documentation and understand what is promise.all and promise.any. Okay, so now that we understood what is promise, now let us understand the final piece of the puzzle, that is async await. So what is async await basically means? Let us try to understand that. So basically async await is nothing but a syntactic sugar of promises. As you can see, this is what the promise code looks like. Well, it is better than the callback help, right? You might think it is way better than the callbacks and callbacks whole. The callback help, the code looks way better. But is there a way that we can make this code a bit more better? Developers thought about it a lot, and then they come up with an idea of async await. Now basically using async await, we can make this code look like much more better. So async await is nothing, it is just promises only, but it is implemented in much more better and smoother way, right? So how to implement async await, let me show you. So for that you need to create a function with the async keyword, right? So you just need to write this async keyword and you need to create the function. So let's just say we want to fetch some kind of a data here. So I'm going to name this function as fetch data. Let's just say, let's hope I have commented all the code. Yeah, I have commented. And now here this fetch data is responsible for fetching some kind of a data. Now for that what I need to do is I need to get some kind of a data, right? So let's just say I'm making some kind of an API call, so I need to get it data as a response, right? So for that I'm going to declare a variable as a response, and I'm going to type this await keyword. So bear with me, I'm going to explain it to you one by one. Let me type the code first, and I'm simply going to write this fetch keyword, and here I'm going to enter the API here. So for that API we have this JSON placeholder API. You can type in the Google JSON placeholder and you're going to get this link. You can come and you can click and scroll a bit. You're going to get this pre-built API, which is going to give you a list of to do. Okay, and what you can do is you can come up here and you can paste this. All right, and now what is going to happen is let me explain it to you. First, you have written this async. So as soon as you write async, it is going to make this whole code asynchronous. All right, so as soon as you type async in front of this function, now this whole function is asynchronous. Now after that, I am making an API call here using this fetch. All right, using this fetch keyword is basically going to fetch the data, which is the to do data in our case, by making this API call from this URL, right? But as you all know that API call may take some time. As soon as you make an API call, it is not going to give you that data immediately. It might take some few seconds to get that data. So well, that time you don't want JavaScript code to move to the next line and JavaScript engine to start executing the code that is 69 number lines code, right? Let's just say you are stuck here in 68 line, and here the data is being pulled, but you don't want that JavaScript compiler to go to the line number 69 and start executing code. Why? Because line number 69 may depend on this data that we are getting, right? So for that, you want to say that to the compiler, hey, wait, until I get that data from that API, you are not going to move towards the line 69. You are going to come and you are going to wait in line 68 only. So in order to do that, we use this await keyword. I hope now the doubt is completely clear why I have written this await. Because if I don't write await, and if I simply write fetch, and if I try to get the data and store inside this response variable, and if I try to log this response, let me type this response. If I try to log this response, I won't be getting data. Why? Because the JavaScript code is immediately going to assign this fetch, right? And the data might be taking some time to come from the server, but it is going to immediately assign this fetch towards the response, and it is going to log this response. It is not going to wait until the data comes, right? So I want to make sure that JavaScript engine waits for that, right? So for that, we write this await. Now, as soon as I write await, now it is going to wait until and unless the data comes in. So either that might be some kind of an error or success data, that doesn't matter, but it is going to wait until we get some kind of a response from the server. And once we get some kind of a response from the server, it is going to assign that response towards this response, and we can log that response and see. I hope now async await is clear. So this is async and this is await. So together we call it as async await. Now what I can do is I can simply come here and I can simply call this function as fetch data. Now let me go to the code and let me copy and come here and let me paste out here, right? And let me hit enter. Now here for the first, ignore this error part and focus on this part. Here what we got is we got promise rejected, so that's why hence this error. But ignore this rejected part, ignore the error, and look here what it is written. So it is saying that promise is in pending state. That means we haven't got all the data fully back. But I told you, right? So we are using await keyword to wait that data, and we actually get that data but for that there is one more label. So what we need to do is we also need to write await keyword, and we need to wrap this data, and we need to await for the response as well. So here I'm going to write this variable, and I'm going to simply say await, and I'm going to write response.json, and then only what we can do is we can extract that data completely properly. All right, so let me come here. Also guys, one more thing what I did is, well, I was copying this code into the console, and due to some issues it was continuously giving me error, and I figured it out that I need to run this via index.html. So I just created .html file and link this app.js in order to make sure that API call is happening smoothly. And now if I come to the browser here, and here I'm just calling, as you can see, I'm writing async, I'm waiting, And then right, so let me log the response also. So I'm going to show how the response look like to you, and then I'm getting the response here from that, and from the response, using the response.json, I'm grabbing that data. All right, now let me come here and let me refresh properly and show you. Right, so this is what response basically looks like. All right, so whenever we make an API call and we try to store the data inside the response, this is what basically the response look like. It's pretty much gibberish. We're getting all the bunch of data, but we are not getting the to do that we are expecting. So in order to get that to do, we need to scrap that to do out of this response using response.json. So that's why we do await response.json, and we get that to do and we store into the data variable. All right, and then we log the data, and then we actually get the actual data, and hence here we got the actual to do data, which is completed false, title and user ID. Right, so this is a fake to do that we got using our fake data. Now I hope you understood async await, and I also hope that you understood the complete concept of asynchronous JavaScript, the call stack, execution context, and all the asynchronous concepts in JavaScript. If you like this video, please hit that like button and subscribe to this channel, and I will see you all in the next video.